Welcome, everybody. I'm Ole André Valdanos, and I'm with the research team here at NowSecure. I'm also the creator of Frida, which I'm going to talk about in this session today. Specifically, I'd like to go through what's new in Frida over the course of the last year. So, for those of you who don't know what Frida is, it is basically a way to observe and reprogram running programs. It's a toolkit to let you do that. So it's a set of APIs that let you build tools that observe and reprogram running programs, essentially. The technical term is a dynamic instrumentation toolkit, so that's what it is. And it's scriptable, so you can do this with a tight feedback loop where you don't have to compile and deploy and observe, and that is like a short feedback loop where you can adapt your instrumentation as you're observing a running program. It's also cross-platform, so you can take what you learn with you to different platforms, and you don't have to learn a new toolkit as you're changing platforms. It's also open source, so we all can work together on improving it. And we're using it here at NowSecure for security testing, for like automated security testing at scale. So looking back at the last year, we've had 30 releases, quite a lot. And there's been one API break just now recently with Frida 16, yay. And we've had close to 1,400 commits and 26 contributors, which is pretty awesome. One of the big new things is that we now have a native Frida compiler. I'm really excited about this one. What I've been wanting to do for years is to streamline the developer experience for JavaScript in Frida. As a developer, I might start out with a really simple agent, but as it grows, I really start to feel the pain. I may want to split it into multiple files. I may also want to use some module packages from NPM, so I don't have to reinvent the wheel. For example, Frida Remote Stream, which we have on the NowSecure organization on GitHub. And later I might want code completion, type checking, refactoring, and so on. So then I might want to use a TypeScript and bring in the TypeScript compiler and so forth. But since we have been piggybacking on amazing front-end web tooling for all of this through the years. So we already have the pieces to the puzzle, so we can use a bundler like a Rollup or Webpack or what have you, and that lets us combine the source files into a single JavaScript file that we can, or blob of JavaScript that we can load with Frida. We can use a plugin to get interrupt with packages from NPM, and we can plug in like a TypeScript plugin to get TypeScript support. But all of that is a lot of configuration and fiddling to get things set up. What I ended up doing was to create a tool called Frida Compile, which would do this plumbing for you, would put things together, like the tool building blocks that you need, and put in place some reasonable configuration defaults, basically for what makes sense in a Frida context instead of a web or Node.js context. Still, you would need some boilerplate, like a package JSON, TS config JSON, and so forth. So it's not really a great experience. So I kind of tried to improve on that by publishing a repo on GitHub called Frida Agent Example, which you could clone and use as a starting point. But that's still a bit of friction. So later, Frida Tools, if you do like pip install Frida Tools, you get those. Has a semi-new tool called Frida Create. But even with that, that will generate this skeleton for you. But even with that, we're asking the user to install Node.js and deal with NPM. And they might also feel confused about the JSON files just sitting there. There's a lot of noise to just get started writing some code. It's a lot of distractions, potential distractions from what they wanted to do in the first place. So that's when it struck me that what if we could use Frida to compile Frida Compile, so we can actually run this compiler inside of Frida's JavaScript runtime. We could then just put API in front of this and allow this to be used from C, Python, Node.js, etc. This would then be using the system session in Frida, which is a somewhat obscure feature where you can run scripts inside of the process that hosts Frida core itself. That would be like if you're using the Python bindings, that would be the Python interpreter. That's the idea. So we can load the compiler as an agent and we can communicate it with it, and we can expose it as an API. And we don't even need Node.js and NPM to be installed in that case. And tools like the Frida REPL can just use this compiler as well. If a user wants to load a TS file instead of a JS file to load TypeScript, it can just do this behind the scenes. And that's exactly what we've done. So I'm super excited about to show you how this works. So let's have a look at how we can use it from Python. So let's create explore.py. We're going to import Frida. I have already done pip install Frida here, so I have the Python bindings. And then we're going to do Frida compiler to create the compiler instance. And then we're going to do call on this object, the compiler object build, and we give it a path to the file. So we'll give it agent.ts. And that's it. That's all we need to actually compile something. So now if we were to go here and run this, it would fail with compilation failed. And now we might want to know why it failed. So let's hook up diagnostics callback. So the compiler has a signal. It's called diagnostics. So we can do compiler on diagnostics and implement a callback that gives us the diagnostics. And then we can print the diagnostics that we get from the compiler. So if we run this again now, we should see something a bit more useful. So now you'll see that on diagnostics gets called. It's given a list of diagnostics. Each one is an object. It has a category, like error here, and the text is file blah blah agent TS not found. And that's pretty obviously correct because we haven't created a file. So let's just create it. So let's now write our agent. Hello, Frida, and then Frida.version. And try to compile this. There we go. So we actually, if we do like got bundle, what we get back is a string, and if we just print that, you should see that this agent that we have here compiled into this. So we have a source map and the JavaScript code that was generated. The source map allows gum.js in Frida to translate line numbers back to the original source code. So a given line in the generated JavaScript here back to the original TypeScript code that was written. So that's optional, can be disabled. Yeah, so we have the files. This gets a bit more interesting if, as I said, you might want to split your logic into across multiple files. So say we refactor this, and so I like to have a log.ts, which exports a function log. And that just calls console log with the args that were given. So now we can do from the other file here, import log from /log.js, and here we're using JS instead of TS because it's the path at runtime. Okay, so if we now compile this, you should see something a bit different. So now you can see that there is agent.js and a log.js. And this weird looking format here with this package emoji is how we're able to represent a bundle of ECMAScript module sources. So we're using the same API in Frida to load a script from a string. And since this starts with this emoji, it wouldn't be valid JavaScript code, since we need a const or a let or a var prefixing any variable to declare this. So this wouldn't be valid code. So the runtime checks for this, and if it sees this, then it interprets the part that's following as the list of files, and then loads the different parts as ESM modules or ECMAScript modules. And that's pretty cool. We can now use the REPL in Frida to load this. Say we actually did like with open underscore agent.js and write that out, the bundle that we get. Look here now, there's only these files, but if I run the compiler, now there should also be an underscore agent.js, and that contains the generated code. So we can now load this with a REPL, and here we go. Hello, Frida 1600. Now, what you might then want to do is you can also now we have used the build API, you can also use watch, so you can easily just do watch and then implement another handler, signal handler for the on output signal, which gives us the bundle, and then we can write that wrote new bundle. So, and this is how you would implement watch mode, where you would continuously recompile. So here you could actually load the script. But what's cool is that the latest Frida tools actually uses Frida compiler under the hood, so you can do just -l agent.ts directly, and it will compile it on the fly and load it. And what's cool here is that you can do hello Frida testing, just change this code, save, and here we go, it's live reloaded. So this uses this watch mode that I showed you here at the API level. So whenever any of the input files change on disk, it will reload the script. So yeah, that's the new cool thing in Frida 16, or actually 15.2.0. But in 16, we made this really, really fast. That's another part of the exciting things. Just to give you an idea, on like a modern desktop system, this used to take a few seconds to boot up and just compile a tiny script like this, and now it's done in a few hundred milliseconds on the same system. So it's now so fast that it can be used, so quick that it can be used for like loading user scripts on the fly, which is like we're doing here. That concludes the compiler feature. Oh yeah, I should also mention that there is also in Frida tools a tool called Frida Compile, which does, perhaps not too surprisingly, do the same thing that we just implemented here. So we can do like Frida Compile agent.ts -o and the file we want. So we can do out.js, for example, and it does the same thing. And it also supports watch mode through -w and testing 1, 2, 3. We can save and recompiles, and it's really fast to recompile. That's about it for that feature. Another cool thing that was added as part of this work is support for V8 snapshots. A V8 snapshot is the V8 JavaScript runtime's support for starting from a snapshot, so it can restore the whole the state of the VM or the heap to from a certain snapshot. So what I've used this in the compiler to make it start really quick. So we basically do all of the work of loading type definitions ahead of time, a compile when Frida is built, and we warm everything up, and then we save that as a snapshot. And then when you start the compiler, it just loads that snapshot, and it can hit the ground running and just be ready right away. And that's what we're using. But this is also available as an API now, so you can actually use this very easily. Another cool thing is that we have dynamically defined scripts, meaning that a script can load other scripts. So if you're writing a tool that can load user scripts inside of it to extend it with plugin functionality, there is also a new API to do this. Okay, so dynamically defined scripts are pretty useful if you're building a tool where you let users extend things. So the way this works is, say we're cleaning things up here a bit. Okay, let's just start with nothing. The new API here is you can do module script.load, and here you can give it a piece of JavaScript. And that can be just, for example, export const color equals blue. That's our script. And we'll have to put this inside an async function, because script load returns a promise, so we can await. And do main catch console error. Okay, so say here we can do console log script dot color script dot color. Let's try this. Use the REPL again. Load this. Yeah, okay, I forgot an argument. The first argument to script load is the name of the script. So this could be color.js, like this. Here we go. Let's see, script color blue. So script load returns this module's namespace object. So that contains the exports. So here we can export different things, and then we can, from the parent script, we can access those things. It can also import things from us if we wanted to have, if we had an ESM module here that exported things. And you can have one script export something and another script can import that. So this gives us a lot of flexibility with how an agent can have plugins that extend its functionality. Another cool thing that happened in the last year was that we added new file system APIs. So for example, say like in the past, you could do this, you can do new file tmp out txt w, open it for writing, and then we could write testing 1 2 3 to this file out txt. So if we actually, I didn't have to restart this. If I check now in tmp, there should be an out txt, and I can change it to 1 2 3 4, reload, and then here we go. It's writing to this file. There was no way to read actually from a file, so now we can also do that. So say we have EPC password here, we want to read that file. We can do f read line, and then that gives us a string. So we could do while line assign. So we call f readline, assign that to line, and that's not an empty string. Got line. And here we go. It's dumped my whole etc password file. Yeah, we could like trim the end, for example, to remove the new line at the end. This function returns an empty string when it reaches the end of the file. Similarly, we can also do read bytes, and say we want to read 4 bytes, for example. This returns an array buffer. So just to spell that out, I can show you, can do this. And then that means we can do hex dump data and say true and dump that. So we can also read binary data from a file now, and not just lines. We can also read text, which will return a string. And yeah, that's what we got here. And one more thing, we can also seek now. So we can seek to offset 10 and then read from that location. Yeah, so here you can see I made a mistake. On line 6, yeah, because calling hex dump with a string, that doesn't make sense here. Yeah, there we go. We can seek to a different offset, and there we go. And you can also omit the argument, and we'll read the rest of the file from the current position. But there's also, if you just want to read the whole file, there's an easier way now. You can do file read all text. And got. Say we want to read the same file, do like this. And just to show you again, that's the whole thing. We can also do read all bytes, and this will give us an array buffer. So in that case, we'll do hex dump data. Let's see, true. Dump that. And here we go. Similarly, there's file write all bytes and write all text. So say we want to do like TMP secret txt, and we'll write some secret. We can also do that. So we'll now look right here. There shouldn't be a secret txt. So let's run this script. And now there should be. And it contains some secret, which we wrote to it. We can also do write all bytes and say we want to have some data here. I'm just going to get the first module, which is the process itself. I'm going to get its base address and read the first 250 or say 32 bytes and write that to secret.bin. So that doesn't exist. Let's run this, and now that should be a secret.bin here. And if we hex dump that, you'll see that we just wrote this binary data to it. And this is a Mac-O header, as you might recognize here. Okay, so that's a new useful API. There's also a new checksum API. So yeah, so there's a new checksum API. So you can do like checksum compute. I can show it here, it might be easier. Checksum compute and then say we want the SHA-256 of testing some string, for example, then we can compute that very easily, or SHA-512, for example. But it would be better to, if we write it here and we use here in TypeScript and we specify an unsupported algorithm, then we should get a compilation error. Argument of test is not assignable to parameter of type checksum type, so we have to specify a supported one. So MD5, for example, this works. And there's also an API that's you can do new checksum SHA-256, and then you can do C update, and then putting things together, we can do read all text from some file on file system and read all bytes of some other file here, and then call toString on it to get the digest at the end. Actually, global.c equals C. Get string, sorry. Get string. And get digest. Get string, get digest. Which returns an array buffer, so we can use hex dump to dump it. So yeah, we basically create a checksum object, we feed it the contents of 2 files, and then we get the digest as a string, and we can also get the raw representation of that as an array buffer. We also have improved OS support, so that means Mac OS 13 Ventura beta is supported now. We have Android 11 to 13 supported, and we have also now support FreeBSD, which is a new OS, to expand on the OS support, and quite a few other things. And we have revived support for QNX and the MIPS architecture. MIPS 64 and MIPS 32-bit, Little Endian and Big Endian are once again supported properly and covered by CI. There's also been some exciting Stalker performance improvements on x86/64 and both 32 and 64-bit and ARM64. So what I heard is that in FastBench, we're able to either match or beat QEMU. So that's really exciting. And memory scan supports regexps, so you can search memory for not just a raw pattern, but also using a regex. And the Java bridge, Frida Java bridge, now has a backtrace API, so you can get backtraces. Those are really fast and provide a way to deep duplicate different entries, different backtraces over time. And we also have better symbolication. And finally, we have migrated the continuous integration to GitHub Actions instead of I used to have a basement's continuous integration system here in my basement where I am right now, but that has finally been migrated to GitHub Actions. And that's about it. Thank you for watching.